Hi everyone, welcome to this explainer session on sort of deploying your first MCP server on the NANDA registry. So today we'll have an in-depth run through starting from scratch and building your first MCP server that can be deployed on the NANDA registry uh, start to finish. So let's get started with that. For that, I'm going to be sharing my screen over here. And we start with this page, which is github.com/AI decentralized slash Nanda hyphen servers, which is our sort of set of instructions and guidelines that you can use to build your first MCP server. In this set of instructions and guidelines, we give you all the package installations that you need, all the steps that you need to follow, as well as a very simple initial MCP server that already works over here, which is a weather MCP server. So first, to get the hang of this, let's start by taking this example code for the weather MCP server that's available in uh, the Nanda server's GitHub repo and see how it works. See whether it's performing as we expect it to perform. So to get that started, first let me copy the example code given over here. Let's go to my code editor. You can use whichever one you want. Uh, Let me paste the code. Let me save this. And we call this server.py. So that is the weather MCP server. Now let's follow the package installation steps. So we've given all the dependency packages that you might need over here. Uh, this shows you how to do it with a Python virtual environment, which you can directly follow. I will, in this video, just for diversity, show a slightly different procedure of using a Conda environment and a Conda environment. So first, let me create the Anaconda environment container over here. I'm using Python 3.11. Uh, you should be able to use anything beyond 3.9, and that should work well for you. So I have set up the environment. Let me go back, change to the correct directory. Um, and let me activate the environment. Great. Once we're done with that, let's start installing the dependencies. So first we install pipmcp. This should take a bit of time, but hopefully this gets done quickly. While that is getting done, uh, we do not particularly need this pip install command. So let's directly move to the next one, which is this set of pip installs that we need, mostly for the networking. So note that most MCP servers that you would have built till now would have used STDIO, standard input output communication protocol, because the MCP server is on the same system as the host, which is the cloud desktop in large cases. In our case, because we want the MCP server to be hosted remotely, we will be using an SSC transport based architecture. And so all the examples bake this in into the example code. So that being said, let's copy this set of installs that we need. Let's go back here. In the meantime, MCP package is installed. So we'll just go and do this installation. All of the requirements are anyway satisfied. So let's clear this to have a clean workspace. And now let's see whether Nanda, we have the Python server or the server weather server code already in there that we've saved. So let's go in here uh, and to run, let's see whether there's a run command. But I believe all you need to be doing is just run here. All you need to be doing is just do Python server.py, and this should be running the server. So we'll wait for this to get sort of spool up. And once a good sign that at least the server is up and running is when it gives you this sort of localhost link. And just to confirm that all is good, we'll go to our browser, paste this in, and looks like it's running correctly. So looks like it's hosted right now. So now with that being said, we have the server running correctly. Just take in the code, install the dependencies, and the server is running correctly. The next step before deploying the MCP server to cloud is to check that all the functionality is working properly. And for that, we use what's called the Model Context Protocol Inspector. So for this, just take this command over here, go to another terminal tab over here. Let's clear this out. Go to another terminal tab and just run npx Model Context Protocol Inspector. Needs to install some packages. So just say yes, let it do whatever it needs to do. And hopefully the inspector should be up and running at this URL. So the GitHub provides you instructions to debug in command line, but I'll show you by using a more sort of UI-driven approach. So just copy this link that it has shown over here and paste it on a separate tab of your browser, and this should open the Model Context Protocol Inspector. Once you're there, choose the SSE transport type, then find out where your MCP server is hosted currently locally. Paste that here. Remember to add the /SSE at the end and hit connect. If it's hosted correctly, you should get a connected command over here, connected response over here. Then you can go to tools. You can list the tools that your MCP server allows for. In this case, this MCP server allows for two tools, get weather alerts and get forecast for a location. So let me click on get alerts. I need to provide a two-letter code for the state. So let's say I click on Massachusetts, MA, I run the tool and success. So this is what the MCP server provides for a weather alert tool. So it looks like it's successful. It's giving me a weather alert for all of Massachusetts as expected. And this means that the MCP server is working correctly and it's ready to be hosted. Great. So with this, we use the example code given on the GitHub repo over here. Went from scratch, created a new environment, installed the dependencies, run the server, and showed that it works properly. Now what we will do is build our own MCP servers from scratch for a new sort of setting and task and see how that works. So let me first clear everything over here. So I close this. I end my MCP server, clear this, end the MCP inspector, clear this, go back in directory, go to my new directory that I'm going to be talking to you about, and let us get started. So the simple MCP server example from scratch that I'm going to be showing you how to deploy is this example of a simple office supplies inventory sheet that I have with various different items. This could be the inventory for a shop or a store or an office, whatever be it. This has a bunch of items. They fall under various categories: quantity, price, supplier, location, so on and so forth. Now I want to take this inventory sheet and build a simple MCP server out of it. All I have while starting out is a CSV file that this inventory sheet links to, which is in this directory, Office Supplies Nanda, that I'm calling it. Just this inventory.csv, and we will go from there. So what I need to do is I want to build an MCP server with two functions. The first is sort of getting a list of all the items in the inventory over here. And the second is, given the name of a particular item, get all the attributes of the item, such as item ID, category, quantity, unit price, supplies, all that stuff, all that fun stuff. Awesome. So now Uh, you can, of course, as I mentioned, follow the example code given over here. So you have a weather example code given over here, and all you need to do is change the name of the MCP server and define your tools. So tool number one and tool number two, wherever they are. And if you define your tools correctly, that's all the changes that you need to make. And you can do this manually, but today I will show you how to do this in an even simpler way using what is commonly known as vibe coding by using any LLM-based assistant. Uh, Today I'll use Claude, but you can use absolutely anything that you'd like. And again, the purpose for me to show you this is just to show that this is so simple that you can just have a simple text prompt and Claude can do it for you very quickly. So let me go to Claude. I've started out a quick prompt over here, which is here is an inventory CSV sheet. So let me actually attach that uh, into the Claude chatbot. So here is an inventory CSV sheet. Uh, I want to build a model context protocol server out of this sheet with two functions: get items, return the list of all items in the inventory, and get item info. Given a particular item, return all the attributes for that item. Below, I'm also including example code for a working weather MCP server. So let me copy my weather MCP server code over here and paste it here. It goes into Claude's context. Take this code and just modify it while keeping fundamentals and structures the same as the weather MCP server to ensure that my CSV inventory MCP server works as I described. Uh, be careful and ensure that the code works correctly. Let's ask Claude to figure this out. In the meantime, let me go to my IDE and open a new folder, which is Office Supplies Nanda. And we can create a new file over here while Claude is doing everything that it needs to do to give me the code. Let it figure this out. So as soon as Claude is done analyzing it, it's going to return me a bunch of code that it's written. And all I am going to do is, of course, wait for Claude to write the code and get the result. So looks like Claude had an issue with reading my inventory.csv file. Not entirely sure why, but let's see. It could be because Claude is unable to handle sort of CSV files. So what we can do is let's try something else. So just for the sake of diversity, I'm going to be trying ChatGPT and hope that it works with that. I'm doing this on the fly with you. So uh, let's see how ChatGPT performs on this task. So same prompt goes into ChatGPT. I give it my inventory file and I give it my example server code. And let's see what it does. Great. Looks like ChatGPT was able to read my inventory.csv file, so it'll do whatever it needs to do. Again, using the same structure that we talked about earlier. It gave me a Python file. Let's see if this works. So copy the code, paste it here, save it, again name it server.py. and let's see whether this works. So my content environment is called weather.py. You can call it whatever you want. It's called weather.py because I'm using it from the same previous example. But let's sort of do Python server.py and run it. Looks like it needs one more sort of package. So I'll do pip install pandas. That's a new package that my custom MCP server requires. So we'll wait for pandas to download, get installed correctly. And once that is done, which is any minute now, awesome. We can run Python server.py again. Let's see how that works. Just waiting for the server to be up and running. And looks like it is. So let's see how this looks. Again, same process, copy paste. Looks like there is a root page. All we need is something to be over here. Next step is to have the MCP inspector running. So let me copy the inspector, go over here, same process, it's on the same port, so we connect, click on tools, list tools, get items, run tool, and looks like it works. So I ran the tool, it gave me a list of all the uh, items present here. And if I click on get item info, so first let me run get items. Let me take a name of a particular item, click on get item info, run the tool, and looks like it's able to return to me all the details about this item. So, so in front of you, I have taken an inventory.csv file that I have over here, taken the example weather code that I had, just defined the functionality that I need, uh, put all of that into first Claude. I tried it. It wasn't able to read the CSV file. Maybe I had to supply it in a different format for Claude to be able to do it. But I just thought it would be faster to try it on ChatGPT, gave it the CSV file, what I want from my MCP server, the example weather API, it gave me code. I just ran it and perfect. Uh, I showed you that the server is working perfectly with MCP inspector and all running correctly. So at this stage, I have code for a working MCP server. All looks good. Code works perfectly, which means my server is ready to deploy. Uh, this was the first part of this video. So as a recap, I showed you this resource that we have at github.com/aidcentless/nanda servers, where we have a full README that tells you exactly what you need. You start by creating a new virtual environment. You can do a Python virtual environment. You can do a Conda virtual environment, whatever works. Install MCP, install some simple dependencies, install anything specific for your project. In my case, it was pandas. And then you are good to go. After that, take your CSV file in this case, write an simple MCP server around it. The only thing that you need to change on top of the weather example that we've given you is change the name, change if you need to do an API call, change that. If you're using a CSV file, add its path. So do those changes. And that is basically about it. And of course, change the tools that you need to use. In this case, there were tools related to weather, but you can define your own MCP tools. That is basically about it. With all of this, you should be able to have a running MCP server that you can then test out using the Model Context Protocol Inspector that I showed you. All right, welcome now back to the second part of this, which is now that you have a running MCP server that has been tested out locally, our goal right now is to take this MCP server, deploy it on a public endpoint, then register it on the Nanda registry, and then show that it works along with the Nanda host. So for that, first step is, in addition to the server.py and the inventory.csv that we already discussed and tested out, we need a requirements.txt. So you can just run this command, which is pip freeze, and pipe it to requirements.txt, which I've already run up above. And once you do that, you should have a requirements.txt that includes all of the requirements that you need. In my case, I'm going to be showing you how to deploy it on AWS, Amazon Web Services. And really, for any public endpoint that you will deploy it, whatever service you use, you also need to uh, create two more files, and I'll show you where you use. One is a build shell script and other is a run shell script. So during the build shell script, just sets up the virtual environment, installs all the dependencies from the requirements files, and ensures that all the packages that are necessary are built and run. The run shell script will just load the virtual environment and then run the server.py file as we need it to on the public server to ensure everything works correctly. Great. Now that we have all of this running, what we need is to take all of this and upload it to a public GitHub repository. So in the next frame, I'm going to cut to me having uploaded all of these files to a public GitHub repository and taking you onward from there in showing how to deploy an AWS server. Awesome. So I'm back with uh, all of my code files, the 5 files: inventory, requirements, server.py, and the build and run shell scripts, uh, committed onto my Office Inventory Nanda GitHub repository. Uh, One thing to note as you're committing all of this onto your repository is, before you commit your build and run shell scripts, remember to run this command: chmod +x build.sh run.sh. This enables for it to run properly on the server. Uh, Great. With all that done now, we have the code on a public GitHub repository. Now let me take you to my AWS console and show you how I will go ahead and publicly host this. So I'll go to AWS App Runner, create a new App Runner service, uh, do it from a source code repository via GitHub. This is the pseudonym for my GitHub page. I will go to Office Inventory Nanda, which is the name of my repository. Source directory is as the root. I'll allow it for automatic deployment, which means every time I recommit to the repo, it'll recompile and run again on the server. I will configure manually. So I'll use Python 3.11, which is the setting I tried locally. For build, I do /build.sh. For run, I do /run.sh. Port has to be 8080, which was what we used in our experiments as well. Do next. Uh, my service name is, of course, MCP, Office Inventory. This can be anything. If your project requires any environment variables, you can do it from here. Mine doesn't. And then all good. Click on next. Verify that everything works well, and then just go ahead and create and deploy. So uh, I will pause the video now as this is deploying, but as soon as I come back, this should be deployed and ready to go, and I will take you through how to register it on the Nanda registry. All right, we're back, and the MCP Office Inventory server is now up and running on AWS. All good on the first shot, so looking good. Uh, the URL is over here. This is the public endpoint. If I see, it's as it was locally. Now, before we go ahead and register on the Nanda registry, we'll once again test it out on the MCP inspector. So again, switch on, get the MCP inspector up and running, take this URL over here, But this time, instead of giving it a localhost endpoint, we give it a public endpoint like this and connect. Looks like it's connected. I list the tools. Looks like all working well. Looks like everything is working perfectly. So that's great. All working perfectly. The MCP server is working correctly on the publicly hosted endpoint, and we are good to go to register on the Nanda registry. So let me go to ui.nandaregistry.com over here. Log in. I already have an account. So let me go ahead and do that. And let me create a new server. So I'll go to my servers. I'll register a new server. Uh, Supplies for office inventory is what I'll call it. I'll just write this out very quickly because this is a demo MCP server. Items in the inventory as well as attributes for the item. Then I will go ahead and take my public endpoint, add it over here. Remember not to add the /SSE that the Nano server does itself. If you have documentation, go ahead and add here. I don't right now. I will say this is, let's say, a resource and a tool, but really you can do whatever you want. I'll add a tag of this inventory. I will go to configuration. I don't want to do any of this. All looks good. I confirm and I'll register the server. And that's it. All looking good. And I have a working Office inventory MCP server over here. So now, if I go to nanda.mit.edu and I go to the Nanda host over here, uh, I already have my Anthropic API key on the Nanda host. You can put yours as well. And as soon as you save the API key, now you can go to the registry. You can refresh it. Uh, And here is, this is one I had done earlier, but this is the one that we just added. So I'll add this server on my current host. I'll ask it, what tools do you have access to? Or should ideally think about it locally. And it tells me that it has some other tools that it has access to, but these are the ones that I just defined. Get items and get item info. So if I ask you the question, give me a list of all office items that are currently present in the office supplies inventory. So it should ideally, and on the host on the right side, you can track how the calls are going. So uh, it should put in the call, go ahead and process the message, send the API request, and see what the response was received. So right now it's saying only one item it got returned, and that's just because of the way the MCP server returned items, I think in sequential return calls or sequential dictionaries. Uh, so this is just a tweak of the MCP server that you should make to ensure that it works correctly. But the server itself is working perfectly. So for example, if I have the question, how many items does the, what is the quantity? Let's say, what is the quantity of in the inventory right now? And ideally, it should be able to use the tool uh, correctly and tell us what the number is. And as you can see, it's able to say there are 15, which is exactly what it is. It says where it's located as well as the minimum stock. So this server, of course, needs to be tweaked because the way it is returning the inventory is in multiple dictionaries as opposed to one, which is why the LLM is not able to see all of them. But the server itself is working perfectly, which is great. And that is essentially the goal of this video right now. So just as a recap, you can use so we started with our github.com/AI decentralized slash Nanda servers, the repository which has the instructions. We ran the weather MCP server, showed that it works perfectly. We created our own custom MCP server for office inventory, tested it out locally, deployed it on AWS via creating a GitHub repository, showed how to add it to the Nanda registry. And as soon as we add it to the Nanda registry, we immediately showed that it gets reflected on the Nanda host. Our MCP server is pretty rudimentary, so of course it can be fine-tuned to ensure that the host is able to work with it correctly. But all this very, very quickly, and you can have your MCP server up and running on another registry in just a matter of some number of minutes, as this video reflects. Hope this video is helpful. Hope you can use this to add your MCP servers on another registries, and uh, happy happy rest of your day, and hope to see you on another registry very, very soon. Thank you so much.